In this video, I am going to derive an expression for an power in amplitude modulation. AM power in radio transmission, the AM signal is amplified by a power amplifier and fed to the antenna with ideally pure resistance. Means there are some blocks. Initial is a modulator, then output of that modulator is fed to antenna. Before feeding into the antenna, there is a power amplifier. And this amplitude modulated signal consists of carrier power and two sideband tones. Two sidebands are this upper sideband and lower sideband. That PT is sum of this carrier power plus upper sideband and lower sideband. And AM, it is expressed as VC sin 2 phi FCT, Vm by T, cos 2 phi FCT, FC plus Fm, and FC minus Fm. This is the upper sideband and this is the lower sideband. And where VC and Vm are the peak values of the carrier and modulating sine waves. But while calculating the power, we have to convert that into RMS values. To convert peak to RMS, we may divide by root 2 or multiply by 0.72. So that's why I convert this into RMS value. That is VC by root 2 sin 2 phi FCT, Vm by root 2 root 2 cos 2 phi FC, like just it is a by root. Then power in the carrier and sidebands can be calculated using power formula. That is the P is V square by R, where is the power, V is the RMS value. And R is the resistive part of the load impedance, that is the antenna. Then here we have VC by root 2 sin 2 plus phi FCT, means this coefficient is only VC by root 2. The coefficient is Vm by 2 root 2 and this is the coefficient here. So while calculating power, only we are using those coefficients only. That means those are sufficient. That is Vc divided by root 2 whole square by R, Vm by 2 root 2 whole square, Vm by 2 root 2 whole square by R. So simplification, Vc square by 2R, Vm square by 8R, that is a 2 to 4, and this into 2, that is 8R, Vm square by 8R. Okay, this contains Vc, Vm, and Vm, carrier power, and this is the message signal here. And M, where we have Vm, okay, we can express in terms of a Vc, that is a Vc square by 2R. Vm, so that is M square Vc square by 8R. M square Vc square by 8R. So we replace this Vm with the Vc here. Then PC is PC square by 2R. Means this term is there. Na? This we will call it as carrier power. So that's a simplification. So we derive up to this. Now we'll separate this term. Vc square by 2R, Vc square by 2R into M square by 4. Similarly, M square by 4. We'll take this common. So this is a carrier power. Pc into M square by 4. Pc into M square. Carrier power, upper sideband power and lower sideband power. It is Pc into 1 plus M square by 4 and M square by 4. So hence, it is a Pc is equal to 1 plus M square by 2.